Hello everyone. Today I will cover several topics. First we will explore KubeArmor installation, followed by demonstrating three different cyber attack scenarios, and subsequently we will practically examine these scenarios to understand how KubeArmor safeguards our sensitive data. So let's dive in. KubeArmor is a cloud-native runtime security enforcement system that restricts behavior like process execution, file access, and networking operations of pods, containers, and nodes at the system level. And this is an architectural overview. KubeArmor utilizes LSMs such as apt-get, SLNX, or BPF-LSM to enforce policies at the system level. And KubeArmor agents are deployed on each node within the Kubernetes cluster. These agents monitor the system for policy violations and report back to the controller. Now, the KubeArmor controller is the central component responsible for managing policies and communicating with agents to enforce them. And the eBPF generates detailed alert containing container, pod, namespace identities. So let's move ahead to the next step. So we are using the K3s, as K3s is a very lightweight Kubernetes distribution, enables quick and resource efficient setup for testing KubeArmor's security features in diverse environments and scenarios. So this is the main reason we are using the K3s. So let's begin the process of K3s installation. So it will take 1 to 2 minutes for the complete installation. And once the installation is done, we will move to the KubeArmor installation. So now the installation is done. Let's move to the next part. Now we are installing the KubeArmor. KubeArmor is straightforward to install and deploy, and we are using the Helm method, where we utilize the Helm Chart to install and manage KubeArmor using Helm. So let's proceed with the installation. First, we will install the Helm using the following commands. Let's begin the Helm installation. Now the Helm is successfully installed inside this directory. Now we will install the KubeArmor using the following commands. Let's begin the installation process. Now the installation will take 2 to 3 minutes. And after the KubeArmor is successfully installed, we can begin enforcing security policies on our Kubernetes cluster. As you can see, the installation process has started. Now the KubeArmor is successfully installed and the cluster is operational. Let's move on to the next step. We are using the Nginx deployment for the attack scenarios. To deploy Nginx, we will use the following command: creating a deployment object for Nginx, ensuring at least one Nginx pod is always running. So let's start deploying Nginx. We will test all the policy enforcement inside the Nginx pod itself. Now, as you can see, the condition is met. And which is indicating our Nginx pod is ready. Now move on to the next step. So KubeArmor CLI utility is a tool used to manage KubeArmor, and we will use the Karmor to view policy violation logs. Let's open a new tab and run the following command to view the logs after every policy violations. Let's run this command. It started to watch alerts. Now every policy violation will give an alert here. Let's clear it first. So this is our first scenario. So here the attacker is installing mass scan on a target system for the network scan, and utilize the kubectl to execute apt-update and apt-install mass scan commands, successfully installing mass scan and gaining network scanning capabilities. So let me explain it further. So the impact here is that the attacker can conduct a network scan, identify vulnerabilities and potential attack factors on the target network. And what about our defense mechanism? So what we do is that we enforce the deny execution of package management tools, apt and apt-get KubeArmor policy to block such commands. And the benefit is that after enforcing this policy, it will prevent unauthorized software installations like mass scan via apt, enhancing the organizational security posture and reducing the risk of unauthorized software installations and potential network scanning activities. So let's see it practically. So using the below command, an attacker install a powerful networking scanning tool. So mass scan is a very powerful network scanning tool. It will give you the open ports and potential attack vectors on the target network after you scan using the mass scan. So attacker's first step is to install the mass scan over the system. So what he will do, he will just execute this command and he is able to install the mass scan or other attacking tools, other hackers tools over the system, and can do further exploitation. So let's move ahead. Now we will apply the policy, KubeArmor policy, to block such execution. Now it will block the package management tools like apt and apt-get to install any unauthorized software or any software inside the system. Let's apply the policy. As you can see, the policy is created. Now when we try to install the mass scan again using the same command, it will give the permission denied message. So KubeArmor enhances security with a deny execution of package management tools policy, and it blocks unauthorized apt usage, stopping the attacker's mass scan installation attempt. And to view logs, we can go to the KubeArmor logs tab. Currently it is empty, so let's execute it. Now it is giving a message permission denied because of the policy. Policy blocks the access to the package management tools. Let's see the alert. So now as you can see, we get the detailed alert which we can use for the further investigation. So let's move ahead. This is our first scenario. So this is our second scenario. Here what is happening is that attacker exploit Kubernetes pod service account tokens for unauthorized API access. Let me explain it further. So here in this scenario, the attacker gains access to a compromised pod and retrieves the service account token when the policy is not applied, and the attacker uses the token, service account token, to make unauthorized requests to the Kubernetes API server and potentially extracting sensitive information, manipulating resources, or compromising cluster security using that access token. So what our defense mechanism involves is creating and applying a security policy to block access to the service account tokens. So let's move ahead. Now to access the service account token, an attacker can run the following account. Suppose attacker is inside the compromised pod and he wants to retrieve the service account token. Now what he will do is that he will run this command, and this command fetches the service account token which is used for authenticating with the Kubernetes API server. So what he will do is that he directly run this and he get the information of the service account token easily. So let's see the policy. So this is the policy by which we can protect our organization from such attacks and protect our service account token from such attacks. So what is happening is that it is blocking the access to this directory, and inside this directory the attacker is unable to access any files or anything else which is under this directory, and the recursive is set to true. It means that there are subdirectories inside the service account token which is also block if someone access it. So let's apply this policy. Now the KubeArmor policy is successfully created. So what is the effect of the policy? With the policy in place, if anyone tries to access a service account token within a pod, they will encounter a permission denied error. This hinders unauthorized access, or they will receive a 403 error. So to view the logs for KubeArmor, we can go to the KArmor logs here. Now the policy is in place and the policy is enforced successfully, and now the attacker again retrieve the service account token or not. Let's see. He will execute the same command again. Now he will get the error. Previously he is able to get the information, but now he is getting the error, unauthorized 401 error. Now let's see the logs. Here is the logs which we can use for the further investigation as well. Let me clear this up. Let's move on to the third scenario. So exploiting a vulnerability, the attacker aims to steal data from etc SSL directory, but KubeArmor policy blocks access. They attempt privilege escalation but fail due to policy restriction. So on the defender side, the KubeArmor policy stops the attacker from stealing data and gaining higher access. The defender stays watchful because the attacker might try other ways. By using strict rules and keeping a close eye, defenders make it harder for the attacker to succeed. So let's see the policy regarding that. So this is the policy. So this is the least permissive policy, and the KubeArmor file poster is selected to the audit mode. After the policy enforcement, we need to make the KubeArmor file poster to block mode, as it is the least permissive policy. So this KubeArmor policy will allow access to specific directories for Nginx label pods while restricting certain files from being modified, permitting Nginx and bash execution paths, and blocking write access to specified directory. So now let's apply this policy. Now the policy is successfully created. Now let's change the KubeArmor file poster from audit to block. Now the namespace is annotated. Now let's try to execute this command and check if the attacker is able to get inside the etc Nginx directory or not. Now the attacker tries this command. He got the permission denied error or message. So we can easily see the KubeArmor logs here. Now let's move ahead and check for the network based least permissive policy, but before that let's delete all our previous policies. Now all the previously made policies are deleted. Let's clear it up. So attacker binaries can communicate with their CNC servers and exfiltrate data using a variety of network primitives to protect your Kubernetes cluster. Let's apply below policy. So in this KubeArmor policy, allowing Nginx label pod to utilize the TCP and UDP protocols, specifically permitting access from user bin wget for both protocols within the network. So let's apply the policy. The policy is created. Now we need to annotate our namespace using the block network poster. So let's move ahead. Now the namespace is annotated. Now let's see if the policy is blocking or not. Now as you can see, we get the error could not resolve host www.google.com, because we are only specifying the TCP and UDP using only this command user bin wget. So that is why we are getting this error. Next, now combining process based network control and process based asset access policies will completely secure the container. Below is the must policy of the previous two policies. Let's see that. Now the policy is created. Let's move ahead. And now when executing this command on a KubeArmor protected pod, the policy blocks the command, triggering an audit block. So let's see that. Now we get the permission denied error, and when we see the logs, there are so many logs. So this is the log. So KubeArmor runtime protection for Kubernetes and other cloud workloads. Thank you very much.